Hi, welcome. Welcome to this overview session of Azure Service Fabric. My name is Mark Fussell, and I'm a program manager that works on the Azure Service Fabric team. So earlier this year, we launched Service Fabric at Build, and there we allowed you to download an SDK that you can install on your local machines to build applications with the Service Fabric. Today, I'm going to show you that SDK and building applications, but I'm also going to show how you can take those applications, deploy them into Azure with an upcoming preview that we're going to be launching later this year, so you can run your applications inside Azure. Since we launched and talked about Service Fabric at Build, we've been inundated with customers who've joined our private preview program. We're super excited about the feedback they're giving us, and all of them tell a very similar story about how they're trying to build tier one business critical services that they want to bet their business on using Azure. Whether that service is something that they want for global reach, or typically because the service that they want to run has functionality that they can provide with agility to their customers. You see, Azure has always focused greatly on building applications and building a platform for you. When we originally launched Azure, we had cloud services with worker role and web role. Today, of course, we also have app services that allows you to build high-scale enterprise applications. And where we position Service Fabric for this is Service Fabric allows you to have this customizable platform where you have greater control and flexibility over what you build, but you don't have to deal with the complexities of VMs, and provides a set of system services for you to build distributed applications. We talk about these services as being born in the cloud services, first-class services where you need to have scale, high availability, low latency, all the characteristics you expect of running a service at scale. This is why we built Azure Service Fabric. Of course, originally we built it for ourselves. We run many of our scale services on this, but Service Fabric provides a platform to give you that scale characteristics, high availability, monitoring, diagnostics, HA. And importantly as well, the way we think about how you design your services with Service Fabric is this concept of microservice architecture, where you take the overall service and break it down into smaller parts. Importantly, we wanted to make sure that Service Fabric was available everywhere. Whether it was available in Azure, the cloud, where you could deploy your applications there, whether it was available on Windows Server on-premise, where you can stand up your own data center or your own clusters of machines, or whether you host Service Fabric on other cloud providers. So providing this platform allows you to build these scale-out distributed services. As I said, we built this for ourselves. We run Azure Database, we run Azure Document DB, Intune, many of the core Azure infrastructure services around networking are built on Service Fabric, and more come online each week. And that way, it gives confidence in the platform that we are committed to getting Service Fabric as a platform that we build our own services. And we're thrilled to be able to give you Service Fabric for you to also take advantage of the same feature set. Now, we're still adding more features to this. One of the areas we're still innovating and adding to is the programming models that sit on top of all of this. And I'll spend some time walking through all of those. As I mentioned earlier, inside our preview program, since we announced Service Fabric at Build, we've been inundated with well over 250 customers who've signed up. They range from anywhere in the financial industry, to healthcare, to data management, to IoT. And all of those have been using Service Fabric to help build scalable service that they run. And as we move Service Fabric toward the GA timeframe, many of these customers are going to go live. So we're thrilled to be able to say that the program is growing. You can take part in this preview program today if you would like to get an early preview of Service Fabric before we launch the service as a public preview later this year. So let me talk a little bit about what the service means and what it looks like coming up, and what it means for a service that runs in Azure that you can deploy Service Fabric applications to. At its heart, Service Fabric takes this concept of a cluster, a set of VMs, and stitches them together. And this cluster can grow and shrink. And on that, you place your applications. But importantly, what we provide is we provide a set of system services that get deployed onto these set of machines. And these system services provide all the characteristics of the platform: failover of your services, deployment and hosting, activation of the containers, the discovery of where the services are running, the deployment of the binaries into there. And these system services as a whole allow you to provide the capabilities that we saw earlier inside the platform. Now, in terms of the service, what will happen is that when you stand up these clusters, our Service Fabric resource provider will come along and upgrade these system services in conjunction with you being able to deploy your applications. So you don't have to care about how the system services run, how they get patched, how they get deployed, how new features arrive there. You can focus on simply building your applications. Now, from an application view perspective, we think about when you build an application with Service Fabric, it's a group of what we call microservices, pieces of code you deploy across the cluster. Typically what happens is we activate containers, whether they're sort of Windows containers or the up-and-coming Windows containers or processes, and then these applications get deployed inside those containers and scheduled across the set of machines depending on the available resources that are there. So this group as a whole that we call an application, a group of microservices that get deployed consisting of pieces of code that you run. So let's take a look first at setting up and deploying a cluster inside Azure, and then I'm going to use the SDK to deploy some applications to it. So I'm going to switch here now over to the Azure portal. And this is an example of our preview portal here. I'm going to go in and launch and create a Service Fabric cluster. I'm going to search here inside the marketplace, find a Service Fabric resource provider here. I'll just let this reload a moment as I get back into the portal. And here it comes back again. So I'm just going to search inside the portal here. And I find a cluster here. And what I'm going to do is I'm going to create a brand new cluster to deploy these Service Fabric applications to. So the first thing I can give it is I can give it the Azure name, the name of the cluster. I'm going to call it AzureCon 2015. I'll just move this to the center of the screen here. And given that all Azure Service Fabric clusters are also resource enabled, I can include this part of a new resource group. So I'm going to include this part of a new resource group here. And this Service Fabric cluster is going to be included as part of the Azure resource group. I'm going to deploy this into a particular region. I'm going to choose a Southeast Asia. And now comes the interesting part. Here's a part where I can choose the types of VMs that I'm going to deploy it into. We have a range of the VMs. We have both the A size and the D size. And as we get towards our GA and a public preview, you'll be able to set all types of VM sizes inside here. So I'm going to pick the A size VMs inside here. You'll see as well I can set the size of my cluster here. Today there's just certain defaults. Inside our public preview, you'll be able to choose the size of your cluster. I'm just going to choose a size 5, and then I'm going to give it an access account. So if I needed to RDP into this machine for any reason to do some diagnostics, I'm able to. And now I've set up that password, I create this, and now it's a simple matter of one more setting that I can do here. The last thing I'm able to do is to set security in this cluster. I can either have a non-secure cluster, or more typically, we secure the overall cluster, the communication between the actual machines themselves, as well as how you access itself with X509 certificates. And all these certificates can come from Key Vault and get deployed on a set of the machines. For now, I'm just going to set this as no security. And then the final thing I can do is I can open up some application ports here on the load balancer through Azure in case my applications need particular ports open on those sets of VMs. Having selected that and these node configurations, I can simply tell Azure to go off and create this cluster, and you'll see now that this new cluster is being created for me and provisioned inside my subscription. Like all great demos, I have a cluster already pre-created here for me, so we can see what this looks like. You see this one here is called cluster number 12. And the important thing is if I go and open up this cluster and we go and look inside it, you'll see that I can look inside the resources of this cluster, and it's no more than a set of existing VMs that I have, some networking functionality, some storage for where we push some diagnostics logs to, and a cluster manager that brings a set of resources all together into a single cluster. So your cluster is the same set of VMs that you have. You can deploy other things onto these VMs, but it has Service Fabric deployed across those, managed as those set of system services. Also in this portal view, I'm also able to go and look at the actual configuration of the actual cluster itself. You'll see here, I can bring up the node view and the health of those nodes, seeing in this case, they're all running successfully. And you can also see that they are striped across some fault domains. And when I do rolling out upgrades, the upgrade domains of this cluster. So this gives me a cluster-wide view that I've created. And I said this cluster is expandable to many machines. I can also see the applications that get deployed inside this cluster and dive down into those. But let me sort of switch to show you another tool that we provide as our SDK that helps you visualize this cluster more. And this is a tool that we call Service Fabric Explorer. Service Fabric Explorer allows me to connect into this cluster. And as you see here in this cluster 12 that I deployed inside Azure, these are the system services I have running. System services that allow me to do failover, upgrade, and management of my overall applications inside there, leaving me free to deploy my applications inside the cluster. And as you can see here, I've got a number of applications deployed, as well as services deployed inside this cluster. Now you have a cluster deployed. I'm running inside Azure. The next question is, okay, what am I going to build to deploy inside that? And that's where we come to talk about the types of applications you build there. In the Service Fabric world, we talk about two application types. We talk about stateless and stateful. The stateless are very familiar to what you have already. Concept of cloud services, where you have worker roles and web roles, or you deploy ASP.NET applications. And in essence, the state of those is all externalized to Azure Storage or SQL Azure or some other state store. But Service Fabric also takes us a bit further, where they have the concept of stateful applications. And what that means is we provide database technology. Effectively, we democratize HA and provide that as part of your application runtime so that you can make your applications highly available, not only restarting the actual code, but the data contained within them all. And the advantage of stateful applications is not only does it reduce the complexity, I don't need to have necessary queues and caches between my applications, but it makes high throughput and low latency because the data is stored highly available next to your code. But then an important thing about Service Fabric, as well as providing the inbuilt runtimes that we use to build those applications, you can bring any runtime that you choose. You can deploy Node.js applications, Java virtual machines, NEXE. You can deploy those across a set of machines. So if you have some existing apps with some existing code, and you typically want to mingle that with the new apps you build with some of the Service Fabric runtimes, you can. In fact, it's very common for us to see whole applications where you have a stateless piece like a front-end gateway, stateful pieces that do some business logic or do some computation evaluation, and then some other frameworks that get deployed, such as Node.js web applications as a whole deployed and put together. Service Fabric itself has an SDK, and as well as providing a platform for all these features, we provide two out-of-the-box programming models. One of those we call reliable services, another one we call reliable actors. And both of these help you build applications, because that's what we're trying to focus on as developers, with capabilities where you don't have to worry about the underlying infrastructure. Reliable services in many ways is not dissimilar to cloud services you have today in the concept of you can write these stateless worker role type applications. But it also has this concept of stateful services built in with .NET collection classes. Think of just like your normal .NET collection classes of dictionary and queue, but this time you can use them in a single box programming environment, but this time their state is replicated across other machines. The reliable actors is a very popular framework we're finding with our preview customers and provides another level of abstraction where you simply deal with pieces of code, actors like objects, that you ask Service Fabric to deploy across the clusters of machines. You don't have to worry about partitioning or how you communicate with them or where they're deployed or where they run. An actor can simply represent a person or can represent a device. And now you simply say, deploy these and manage them all for me. So let's get into Visual Studio, and we're going to look at both these types of programming model frameworks, build an application, and deploy it into that cluster inside Azure. So I'm going to switch here over to Visual Studio. Inside Visual Studio, we have a plugin that helps us build Service Fabric applications. I'm going to do File, New, Project. And here I'm going to create a Service Fabric application. If I hit OK here, you'll see that I'm able to look at the application types that I can build. I can do stateless, stateful, or the actor-based ones. I can even deploy ASP.NET 5 web applications into this cluster of machines. So that gives you your equivalent of the web role that you can run that you have today. So think of the stateless services like worker roles, ASP.NET 5 web application, which is now host independent, a bit like web roles, and you can deploy these all into the cluster. So I'm going to choose a stateless service. I'm going to hit OK. It's going to create a project for me. Already on my machine, I'm running effectively a Service Fabric cluster. And when you look at this stateless service that I've built here, you'll see that there's a stateless service number 1. It's very similar or almost identical to how you think about a worker role today. We have a run method. I can simply set a breakpoint inside here. I can build and deploy this application. And now this application gets built, gets deployed onto my local machine. I have Service Fabric running my machine with exactly the same code that I have running inside Azure. There's no difference here. There's no emulator to get in the way. And once this is compiled and deployed to my local cluster, which I can view here inside Visual Studio in the Cloud Explorer, you can see I can hit breakpoints. I can single step through breakpoints inside here, debugging my application. And if I take this breakpoint off and then hit F5 on this run here, you'll see that I have diagnostics information that comes out as part of this service as well, telling me some of the event source information. So I'm fully able to debug and diagnose my service here. Once I'm happy with this, I can now take this application I deployed locally, but instead deploy it inside Azure. So I'm just going to move back here to my Explorer. I'm just going to pull up the connection endpoint for that cluster we created earlier. This is sort of the management endpoint that I'm able to connect to deploy applications to. If I go into this cloud profile here and update this endpoint that I'm going to connect to with that connection endpoint, and now simply do a build and publish here, you'll see that this time I have the cloud option to be able to deploy to with that cluster that I hosted up inside Azure. I'm going to hit publish. Same thing happens. My application gets built, it gets packaged, it gets pushed up and deployed across those set of machines. And now, having tested it locally, I can run it up inside Azure. So I'm just going to switch over to this Cloud Service Explorer, and then we can start viewing this all from here. Inside the Cloud Service Explorer, as well as this node view of the applications of the nodes I have, I can see an application view. So I'm going to expand out the application view inside here. If I just do a refresh inside here, you see that that new application I just built, application type number 7, has been deployed across a set of machines inside this cluster. So rather than just running on a single node on my local development box, it's now deployed across VM1 all the way through to 4. Because in the running production environment, just like a cloud service, I said, run this on every one of the machines. Now, I have this other little handy viewer here that's I have available, and which enables me to view the type of applications that are deployed on this machine. And this little viewer effectively allows me to see a view of where applications are deployed inside each one of the VMs. You'll see here, there's application number 7 I deployed. I also have another application here called word count, which is one of the samples we provide as part of the SDK, as well as the actual cluster monitor and a previous one I deployed. So what I'm able to do is if I go into Cloud Explorer here and I simply stop this node, what you'll see now is the behavior. Imagine that one of these machines failed. I killed off a VM number 0. What happens is that, as that VM starts to shut down, those applications will be taken down. And of course, if there are available resources elsewhere, they would restart there. In this particular case, the machine gets shut down and all those applications disappear. Importantly, of course, we want these applications to be self-healing and to recover. So if the node comes back up again and I restart this node, so I reactivate it to enable it to become part of the cluster again, Service Fabric recognizes, oh, you've had a new VM join back into your cluster. You had policies to say application number 6 and number 7, as well as that word count application should be deployed across it all. So as the node comes back available and joins back into the cluster and negotiates, Service Fabric will look at that and go, I'm going to redeploy those services back inside there and activate them all again. And as far as you're concerned, you had this self-healing application which you could scale out across there. And in due time, my applications now are fully enabled back inside my cluster. So this means that you don't have to worry about failures or scale out. Your applications are deployed against a set of desires and rules that you want in terms of how they get deployed inside the Service Fabric cluster. Pretty good, eh? So that was building an application, deploying it locally, building it and testing it locally, deploying it in Azure and seeing what was happening there. Let's switch now and start to look at another type of application I have here on the active programming model framework. It turns out that our active programming model has become very popular because it simplifies building these services even more. And a very common example is where people push data inside Event Hub, into Azure Event Hub. They can push lots and lots of messages from devices. And then they have actors that simply represent those devices that do some computation on that message. So we have companies who are building IoT-like solutions or data processing solutions where they have a stateless service pulling that data from Event Hub, and then actors that simply represent the devices or the individual devices that represent the code that they want to run. So if I go look inside Azure Explorer here, I have another cluster up and running here. And inside here, I have 2 services running. I'll just zoom in here a moment. I have this Event Processing Hub service, which just like the service we saw before, runs across each one of the machines inside the cluster and acts like a gateway, pulling messages from Event Hub. And then I have this other service here, this Device Actor service, that effectively holds my actors. And every time a message comes in, I activate one of these actors based on the device ID. And I can scale this across as many nodes inside the cluster as I want. I can make this scale across all the nodes, or as I expand my cluster out, the service can scale up. So if I return to Visual Studio here and look more closely at the first service, the Event Host Processor service, you'll see that using the Event Hub processor service, I simply pull out a message from the Event Hub, and then I can, using a device ID that I pull from the message, simply call a get actor proxy to create an actor. And now I can simply call the actual method on the actor itself, giving it the data. So this helps me have a discrete little object that I can call. But how do I define this event process service? Well, this method. This is defined inside my device contract here on my iActor. You'll see here's your process event async message. And there's a couple of other methods inside here as well. And equally, I can define some state that gets managed with my actor here. You'll see here I have some queue and some other data that gets associated, and that makes it highly available and replicated across a set of across the machines inside the cluster. So I don't need to have an externalized data store for these actors. Everything is self-contained and made highly available within Service Fabric. And then finally, I just implement this process event async method. And this is the one where the actor gets called and it does the actual logic of what's going to do. I've asked it to do in terms of processing the information for this particular device. So I have a little simulator here that helps run all of this. On the left, I have a device simulator here that simulates hundreds of devices pushing lots and lots of messages in to Event Hub. So if I start this up here, you'll see it'll start pushing messages into Event Hub for each one of those devices. And I'm able to set some device ranges here for the actors to say, if the message falls out of these values, send an alert. So on the right-hand side here, I'm going to start up this alert-based client. And what this does is it looks at the output queue that the actors are pushing to. And every time an alert is sent from one of the actors, because the value from the device is outside of this range, it'll get pulled up and sent into this particular queue. So this is a great example of how I can build a service that runs at scale. I can run this across 3 machines, 30 machines, 300 machines, scale that service out. But Service Fabric provides this high-level application programming framework that takes all the complexity of building a distributed, scaled-out application across there using these high-level programming models. And of course, in due course, we'd like to introduce many more programming models that you'll see on top of all of this. So, to conclude, today, I talked about Service Fabric. We launched this at Build. We're very excited that we can get the SDK into your hands. You can download and build this locally. I'd love for you to join our private preview program with all those other customers we have today. Later this year, we'll be launching a public preview to be more highly available. And at that point in time, people will be able to stand up their own clusters inside Azure. Meanwhile, please evaluate Service Fabric. We believe it's a technology that is going to help you build those high-scale business-critical applications. And we'd love to hear your feedback, particularly by posting any of that on the forums inside MSDN. Thank you.